Okay, my bad, dogs. I gotta miss, well, it would be today since you were listening to this, but I'm making this Friday. I gotta take Sammy Samulus. And by the way, I did name her Samantha on purpose so that I could call her Sammy for Samantha Samulus. But anyway, that's a side note. But it's really a tough lesson to miss because we're so bad at solving. Oh, sorry, shots fired already. But and then also, this is going to be kind of tougher, but you got to have your formulas out in front of you. Sorry, the rest of second hour plus seventh hour, I didn't give you that little formula sheet slip. I forgot about that. But look at your notes. You don't have to have these memorized. And then the purpose of this solving is you got to do some replacements. You got to use your formulas and do a substitution using those. Now the cosine 2x rules have three different ones. So which one do I choose? You know what? I'm a genius. I just thought, and I always said I don't ever want to use this one, but then I just realized something. If I use this one, look at your formula sheet. If you're like, what is that? I don't get it. Dude, or whatever, come on. Get your head out of the whatever and figure out that I need to look at the formula sheet and figure out which one I'm going to use, and then why would I use this one? Gone. And then what do we have? We have cosine squared x equals 0. 0 over 0 over 0 over. I'm sure you're sick of that. And then square rooting, well, it's still 0. 0 over 0 over. Right, and then where does that happen? That's when x is 0 and r. That's here, these spots. So the answers are pi over 2 and 3 pi over 2 for that. So let's go back to this. What happened here? These are definitely not compatible. So I got to get a formula from my formula sheet that would work for this. And I can't believe I used this one. Actually, that just like in a second, I just realized if I use that one, the sine squareds cancel. Great stuff. Okay, next one. You have no choices on this one. This one has to be the 2 sine x cosine x rule. So understand what a formula sheet is. It means I can replace this with that. And there's nothing else I could do for you on that. If you don't get replacement and substitution, I recuse myself from any other responsibility with your education. You must figure this stuff out. Then what did I just identify? A common factor. So we're going to undistribute that. You know how I lament about people that cannot GCF factor still, even though that's a math 1, math 2, math 3 thing. Still. Cry myself to sleep at night. AB students have nightmares. AB. All right, and then this is X and R. We just had that. It's over here. So if you still don't know what X equals. And then this one here, this is -1. And then where does that happen? -1 over, -1 over, -1 over 1. So that is, where's Y, -1 and R? Well, that's here. That is there. So that's already there. I guess what? We're done. That's weird. 2 questions in a row, 2 of the same answers. Weird, wild, wacky stuff. Now this one, we are going to have to pick a lane. Like where are we going to go from here? Sorry, I just got distracted by my phone drone. Okay, I have to use this one. 2 cosine squared x minus 1. Look at your formula sheet. If you're like bamboozled where I'm getting these from, you're on Pluto. All right? All right, and why did I have to pick this one? Because I need variables to be the same. The other ones have sine squareds in them. Then it would be unsolvable. Now this one I guess I would call, I've been using a basketball reference, 7th hour. This one might be a 3-pointer because of how hard it is for us to factor, some of us. Okay, so, and again, we've been teaching factoring all year long. That's why I lose sleep at night. That the same old stuff is still tripping up students. 2 cosine squared times cosine, doink. And then how do I get -1? One of these have to be positive, one negative. What do I want this one to be? Negative. Why? Because then that's -2 cosine plus 1 cosine. To still not know how to unfoil. Ay caramba. Cosine of x is equal to -1/2. Cosine of x is equal to 1. Finally, some different unit circle values. What's sine of a 30? 1/2. So this is a 60 in quadrants 2 and 3. I had to think about that for a second. So the 60's in quadrant 2. This is 3 pi over 3. Jump backwards. Enabler, Mr. Samuelis, enabler. Enabling the unit circle. And these students that just can't figure out the unit circle. 1 over 1 over 1 over 1 over 1. All right, and that's x is 1, r is 1. That happens in one spot. Right there, which is 0. Let's put that first. Doink, 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 doink. All right. Good to go. I love math. There are 2 ways I could approach this. 2. Which way do you want me to choose? The first way? Okay. So what I could do is use a rule, and it actually works. Cosine x, cosine pi over 2. Look at your rules. Cosine is cosine, cosine. Sines are opposite. Sine, sine, everywhere, sine. Do this, don't do that. Can't you read the sign? And then what's sine and cosine of pi over 2? Well, cosine is 0. I'm going to move that using the commutative property. That is a property. And then this is 1. This is nothing. So you basically have sine of x equals 0, and you may proceed. This is the first way I would have done this. The other way, I think, is a little bit more complicated. And I told you with you guys, I just like to pick a lane. I don't like to show you like multiple ways, then we get confused. 0 over 0 over 0 over. Okay. And then that happens here and here. That's where y is 0. So this is x equals 0 and pi. All right, let's move on. We're flying, man. How many more? That's it. Oh my gosh. Oh my gosh. I have no choice on this. There is only one rule for sine 2x. It's 2 sine x cosine x. And then this is tan x. You know what? I might as well just go ahead and do this right now. What? Because I'm going to write this as sine. Uh-oh, this is going to be a problem. Sine of x over cos. It isn't. Oh, this is beautiful. What happens with the cosines? You're gone. And then what do I have left? 2 sine squared of x equals 0. This is silly. I don't know why this is occurring. Sine squared of x equals 0 over 2, which is 0. And then you square root both sides, you get sine of x equals 0 yet again. These worked out really weirdly. I wish we had some more better results in the math here, that better unit circle evaluation. But really the key is to manipulate the things correctly than the algebra we've already taught. We solved on Tuesday, I believe, without these identities. Actually, we solved 2 different times. One without identities and then one with identity replacements. Now we're just doing another set of identities to replace. Whatever. All right, so this is y over r. And then where's y? We just had that. That's there and there. So that's 0 and pi. Literally just had that over here. So, yeah. So those are the examples. They are what they are. We'll just move on. Right? And then this is kind of weirdly worded. And then it says on the interval, of there twice. You know, so I don't know. Just a little overworded there. But when I look at this, how do I solve this? 1 g of x equals 1. It's kind of weird because look over here. It's not really a solve. I don't understand the word solve on this set of directions. This is kind of like an AP example. When I look at this left side, I almost said right, that just looks like a rule being used, the sine sum rule, which is sine x cosine, I almost screwed that up, pi over 3, sine is the same. I keep doing that for people that might take calculus, that you're going to have to memorize this stuff. You might want to do a little extra work on that and think about that. Hey, what's sine of a 30? That's not 30, Mr. S. Exactly. So it's the other one. And then what's cosine of a 60? Well, it is a half. You know what? I'm going to write that out in front. Commutative property is what that's called. Sine, see how I fit that in there, that I? All right, and then that equals 1. What the heck is this? These all equal to... Oh, I know what to do. Whatever you do to one side, say it. Did you say it? I haven't said anything all year long. 2 times a half is 1. 2 times root 3 over 2 is root 3. Hey, that looks like this one. Letter A. The letter A. Okay, weird. I don't know about the solutions. You didn't really find any solutions. Kind of a weirdly worded question. Then this last one, I don't care what you use, but I will tell you this. This is why we need to know what's going on here. Okay, so cosine of 2x equals 3/5. But I need to know what sine of x is. I need you to concentrate on this. These are different. So I do have an issue. So how do I get x as an angle measure? I do a replacement. And then what does this say? What is sine of x? So therefore, I'm going to do the replacement that has sine squared in it. And then I'll get my answer directly. But you got to be careful. X is in quadrant. I'm pausing for you to think. 2. That's what this cryptic information means over here, which is information you should have seen before. Yes, you have. And then this is, where did that come from? Is that calculus? No, this is grade school. Subtract 1, that's 5 over 5. So whatever you do to one side, say it. I subtracted 1 from the left. I'm subtracting 1 from the right. I'm getting my grade school ready. -2 sine squared of x equals, that's -2/5. Instead of dividing by -2, I'm going to multiply by a -2. So multiply, or -1/2, sorry. All right, said that wrong. Wrong, Mr. Samuel, that's wrong. And then negative, 2. So this becomes 1/5. Now here's the problem. I got to root both sides. And now when I square root both sides, what are you supposed to put in front? Plus, minus. Square root of 1 is 1. Square root of root, or 5 is root 5. I know that's root 5 over 5, so it's one of these two. Now I better read this. What is sine in quadrant 2? And the answer is positive. The other possibility could have been, what if they said 3 or 4? Then I'd have to choose the negative. So you must choose the positive there. You know, so that's not really a bad video. I know in the homework, oh, what the heck? I'm going to go to the homework and do one, and then I'm going to see the bums if they actually do this question or not. And then, you didn't do your homework. Well, I did, like, I might even do 2 of them just to see. This is going to be hilarious. That looks very similar. Yeah, you know what? I'll do number 1. All right? Because I'm a nice guy. No, you're not. All right. Cosine of x minus 1. Just ask my ex-wife. No, never mind. Cosine of x minus 1. What am I going to put in here? I have 3 choices. Well, there's one choice that has only, anyone? Cosine. So that's the one I'm going to replace. That's all I got to do in order to solve these. Choose the one that matches the other variables that are listed in the question. You choose any of the other two, you're done. It's not going to work. It's going to be unsolvable. I'm going to get this side to equal 0. And I swear to dog, if you guys don't start figuring out GCF factoring, I'm going to lose my mind. Take out a cosine. You're left with 2 cosine x minus 1. And then I think we had these answers like in our notes. I'm going to try to find one more that... Actually, I should just do the whole assignment on the video and then see all the bums that can't even watch a video and write all the homework down. Oh, I got the key. I could just copy that, Mr. S. All right, x equals, where's x? Where's x? It's a different x. This is an angle x. These are the x, y, r, circics or ticks. Hey, what sine of a 30? That's not sine. That's the point. This is a 60. All right, so anyway, where do you get 0 for x and 1 for r? There's actually 2 spots for that, here and here. So sorry, you got to be careful on that one. Y could be plus or minus 1. And then these are the 60s in quadrant 1 and quadrant 4. Ah! I said 4 and I wrote 4, right? The 60s and over 3, though. All right, that looks too easy. I did say do at least the odds. I do feel like it's kind of a lengthy assignment. 8 is just another factor like that. I guess I could do one of these. I kind of like doing it like this. I really do. I like doing like these kind of questions. I like just using the rule. You know what? 6 is a little bit more complicated. But you said only do the odds. You're not doing your homework for me then. That too does not. I had someone in tutoring distribute that into that. I threw up on her paper. Like, what are you doing? Blech. All right. So, okay. And then this is cosine of x plus pi equals negative 1/2. And then I use the rule. I use the sum rule. Flip your note sheet over. The notes from Thursday. This is cosine pi. And then cosine is opposite signs. And then this is sine sine. Everywhere sine. Do this, don't do that. Can't you see? And then just keep going. What's the cosine of pi? Negative 1. Again, use the commutative property. And then what's the sine of pi? 0. That negates this. This destroys this. This is gone. You're gone. And then if you could just look at this, divide both sides by a negative, and you get this, which is the answers we just had from the previous question. The over 3s in quadrant 1 and 4. Let's move on. You know, this is too much fun. I don't even want to go home. I might stay here all the way through Saturday and just keep doing math. Because I'm having just a blast. What? What? Oh my gosh. I hate math. 2 terms. Both terms have this name in them. So therefore I can take out a GCF. You're going to love this. I was kidding about hating math. I love math. Because, hey, my silly little friends, what's sine squared plus cosine squared? 1. And then I just had this happen. Yoink, 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 yoink. This is the repetitive. This is why you people that don't know the unit circle, in this assignment alone, the same kind of things keep happening, the same analysis. Where do I get x is 0? You know what? I'm just going to keep going. No. Those that are overachievers, we're going to go ahead and do this one. This is from 2 sets of notes ago. Make a choice, pick a lane. I'm gonna do this one. X squared plus y squared, and then I'm going to end the video because it's only at 19 minutes. All right, and then this is, what's secant? Boy, I wish oh, that's r over x. So secant squared equals 1 plus tangent squared. So that's what I'm going to do. I'm going to get these to match so that I have, so that's not our new identities. That's an old one. It's a Pythag. All right, distribute the 2, and then let's see what happens here. 2 tan squared. I should just write 2. 2 in front, 2 tan squared plus tan squared equals 3. This is 3 tan squared. What? What was that? Oh, I love technology. Oh gosh, when AI takes over, AI is going to know how much I've ripped on technology. I'm going to be the first one to go when the machines take over. Remember all that stuff you were saying about us? Mr. Samuelus, you're gone. 1 over 3, and then square roots. Hey, what happens when I square root both sides? Plus or minus. Whoops, getting a little too excited there. What's the square root of 1? 1. What's the square root of 3? Square root of 3. What is this? This is y over x. This is a 30. Look at your unit circle. Yoink, yoink. 30. This is root 3 over 2, comma 1/2. 1 over root 3. That's tan. That's how you use that thing, you silly little bums that don't know your unit circle still. Pi over 6. 5 pi over 6. 7 pi over 6. That's the beauty of plus minus. 11 pi over 6. The beauty of it. All right. It's been an honor and a pleasure. Oh no, what did I just hit there? How do I get? Okay.